All right.
It's not.
Branston and Prosper don't have to do all the work here. I'm
I
gonna.
need a new copy.
I don't have any copies right now. I'll have to print more.
I guess Prosper do
So
all the work then.
the diagram on the right shows beam A going into a prism, and the prism, it doesn't tell you what it's made of, but this is air. What's a prism usually made of?
Glass.
Glass. And what color of light is beam A that's turning into all these other colors? Yes.
Yeah,
So,
white
and then
light.
it's broken up into all these other colors. And one thing I didn't really ask you, like this is Mr. Yando's review, but which color is this right over here?
Violet.
The one, yeah, that's violet. This would be red and orange, yellow, green, blue, and indigo. So when two waves pass through each other, this is something we talked about before specifically, but we didn't use this generic word.
Do you want to
So
know about it?
two waves pass through one another. No, we did a lot with this. This one and this one.
Okay.
And you get this one. You get a larger one.
Interference.
Is that diffraction, interference, reflection, or
Interference.
interference? And specifically, is it constructive or destructive interference?
Constructive.
Constructive. So I don't know that we really talked about that word, but we talked about constructive interference. But we really didn't talk about that just alone. So how would they do destructive? Because on the
If
test
they
it
were
might be
like-
destructive.
If one was up and one was down at the same time.
Yeah, so if this one was up when this one was here, if they were just shifted over a little bit, like that. When a wave bounces off a surface, like this, like a ball bouncing off, what is that called?
Reflection.
Reflection. This is the Branston show. Branston's doing well.
Prosper's not doing
Briefly describe the law of reflection. So the law of reflection governs this. I'm going to just use this. I'm going to use this diagram to show the law of reflection.
angle of incidence equals angle of reflection.
Yeah, and if I wanted to show the angle of incidence, what else do I have to draw?
Normal.
The normal. Very good. So there's the normal. This is the angle of incidence, and this is the angle of reflection. And these two angles, I'll just write it out. Angle of incidence equals angle of reflection. I don't even think I'm going to need my calculator for this next page. There's no V equals C over N kinds of stuff on here. Shh, Branston, shush. Even though you are answering all the questions here. When light travels from water from air into water and bends, what's that called?
Refraction.
Refraction. And when light does diffraction, it bends too, but what's it bending? What's making it bend?
Something in the way.
Yeah, just obstacles, just bending around. But that won't be on the test. All right. This is the lens. Is this the lens you took out to burn things, or is this the lens Eshok took out to burn things?
Well, that's the one E-shock.
That's the one Eshok took out to burn things. And what happens when light goes through that one? See. So he was protecting the paper. The paper that might have been hit by ordinary sunlight, he was spreading that out so that the paper was going to not get a sunburn. But if, what would the lens need to look like in order to do this?
It'd be convex.
Yeah, this kind of a lens would do it. All right, so B? No, are you being serious?
Then A.
So just look at this. Law of reflection. If light hits this surface right here. Hey, Seb's here. They doubted you too. If light hits this surface right here, how's it going to bounce off? Is it going to bounce off this way? Does that make any sense? No, it's going to bounce off like that. And this one, how's this one going to bounce?
Directly back.
Straight back, but this one is going to bounce over here. So this is
A.
A. All right, the 7 parts of the spectrum in order of increasing frequency. Roy G. Biv. And make sure you know the names that go with these. Red, orange, yellow, green, blue, indigo, and violet. 2 special characteristics of light waves.
They behave like particles.
In what way?
They have gravity.
They're pulled by gravity.
Pulled by gravity can travel through space.
Yeah. Gravity can travel in a vacuum. They don't need any mass to travel in because it's kind of like they have mass themselves. And that's it. So anybody who's taken the final, I was just saying that Mr. Yendo came in and said you can use, we decided a 3x5 note card, you can write anything you want to on it. So somewhere in my big pile of stuff I've got the thing I've been filling out all this time. But these are all the sections. This,
Yeah.
that was